This lesson will focus on indices rules from National 5. An index is another name for a power. In the operation x squared, the 2 is the index. The plural of index is indices. Rule 1. When multiplying algebraic expressions with the same base, we add the indices. Rule 2. When dividing algebraic expressions with the same base, we subtract the indices. Example 1. Simplify part A, h to the power of 4 multiplied by h cubed. Part B, y to the power of 12 divided by y to the power of 5.
Okay, example 1. H to the 4 multiplied by h cubed. Let's keep this nice and straightforward. If the base is the same, which is just a fancy word for later, when we multiply we add. So that simply becomes h to the power of 7. When we divide we check, same base, perfect. All you're going to do here is subtract, because we're dividing. 12 subtract the 5 should give you y to the power of 7. It's as straightforward as that.
Example 2. Simplify part A, 5p squared multiplied by 7p to the power of 5. Part B, 70i to the power of 9 multiplied by j cubed divided by 10i to the power of 4 j.
Example 2, part A, keep it nice and straightforward. When we're multiplying, we know we add the powers. So to deal with our coefficients to begin with, we've just got 5 multiplied by 7, 35. P squared multiplied by p to the power of 5. When you multiply, you add, which gives you p to the 7. Part B. Okay, we're dividing, so we know that we're going to subtract the powers, but let's just deal with our coefficients. 70 divided by 10 is 7, and then take each term individually. I to the 9 divided by I to the 4. When you divide, you subtract. 9 subtract 4 gives me I to the power of 5. Then we have j cubed divided by j. Now that j just is a power of 1, so therefore that becomes j squared.
Example 3. Simplify d cubed all squared. Part B, 4h. Part B, 4h squared all cubed multiplied by 2h to the power of 5.
In example 3a, we have d cubed all squared. Now, there is a quicker way of doing this, but I'm going to show the longer way first of all, and then we can see how you get the quicker way. When you square something, you multiply it by itself. That means d cubed multiplied by d cubed. We now know when we multiply, we check for the same base, and if it is the same base, we add the powers to give me d to the power of 6. What you should notice is that in this instance, if you have an algebraic expression that's to a power raised to another power, you can multiply these two numbers together. 3 multiplied by 2 will give you 6. So there are two options there, whichever one you prefer. If we look part B, we have 4h squared all cubed. So what this means is 4h squared has been multiplied by itself 3 times. So we can either break it out or we can try and be a little bit fancy with it. First things first, 4 cubed. So 4 cubed is 4 multiplied by 4 multiplied by 4. So that should give me 64. H squared all cubed means h squared multiplied by h squared multiplied by h squared. So that should be h to the power of 6. I'm then going to multiply it by 2h to the power of 5. Same base, so deal with your coefficients. 64 multiplied by 2 is 128. H to the 6 multiplied by h to the 5. We're multiplying, so we're going to add. So that will be h to the power of 11.